So first, let's do a t-chart and figure out what this, because, well, I keep interrupting myself, figure out what this function is going to look like. I know it's a function because no matter what I put in, I'm only going to get one answer out. And I know it's a linear function because it can be written in this form right here. Okay, and remember, my x is my independent variable, y is my dependent variable. I'm coming up with just different elements of the domain. So if I'm going to be plugging numbers into this, let's plug in the easy numbers. Like I'm going to be taking a third of stuff. So I'm going to plug in 0 and 3 and 6 and 9 and -3, etc. Maybe -6. So put the 0 in. -2/3 times 0 is 0. Plus 1, you get 1. Okay, so definitely have the point 0, 1. If I plug 3 in, the 3's cancel. Leaves -2 plus 1. And that's -1. So over 3, down 1. If I do -2/3 times 6, okay, so a third of 6 is 2. 2 times -2 is -4. Plus 1 is -3. So over 6, 1, 2, down 3. I plugged in 9. There's -6 plus 1. I'm going to get -5. 2, 3, 4, 5. If I went the other way, -2/3 times -3. So the 3's cancel. A negative times a negative is a positive. So it's 2 plus 1 is 3. So -3 of 3. Put in -6. Third of 6 is 2. -2 to -2 is 4. Plus 1 is 5. So 4, 5, 6, 1, 2, 3, 4, 5. And I think I've established my pattern. Like I could plug the -9 in. A third of 9 is 3. -2 times -3 is 6. Plus 1 more is 7. 7. But see how I could have gotten a bunch of, like, once I established my pattern, I could have just realized that every time I move one way or the other on the x over 3 or back 3, I either go up 2 or down 2. So there's that line. Okay. All right. So we want to get a better way of graphing a line than doing this t-chart. That takes forever. Okay. And that's a good backup. It'll always work and you can figure things out. But, who wants to do that? So let's talk about the slope of a line. Okay. All right. So the slope of a line just tells how steep something is. And it's pretty much, you just kind of, if there's a picture drawn, we can just count. The slope is represented by letter M. I had a kid tell me once they think of mountain slope, like there's a slope of a mountain, so they think M for mountain. But we're going to let it be the slope, and it's telling the rise over the run. Okay, so look back up here. If I pick just 2 random points, say here to here, and I look at the rise and the run. Okay, so to get, say this is point number 1, this is point number 2. To get from 1 to 2, I go 3 places to the right and down 2. So if I were doing rise over run, the rise is -2, the run is +3. That was a slope of -2/3. Okay, if I were picking, like I can pick any 2 points. Let's say I'm picking, let's say A to B. And I want to know how I get from A to B. And I'm counting rise, counting rise and run. Okay, so from here first, start here. To get from A to B, going up and down, I go up 1, 2, 3, 4, 5, 6 that way. And then I go backwards to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I back up 9. So the rise, why did it quit writing? Hang on. overrun would be positive 6 over negative 9, which a positive divided by negative is a negative. 6/9 reduces to 2/3. Doesn't matter what 2 points I use, it's going to reduce down to negative 2/3. Oh, and look, there's negative 2/3, because that number that sits out there where we've been talking about the y equals mx plus b, that m has been the slope. Okay? So think of this. If you're trying to graph something and it has a slope that's negative, that means from one point to the next, the rise maybe is going down, run's going sideways. So the thing that you want to know is when we read a line from left to right, if it's going downhill, that's a negative slope. If it's going uphill, that's a positive slope. Okay? So say on this one, I'm trying to get the slope of each of these lines. From left to right, it's going downhill. Just go ahead and say the slope is negative. And then just find 2 points. Like on the one I did up here, I actually worried about having positives and negatives on the picture because I was trying to describe it. I'm not going to usually do that. I'm just going to look and just count blocks and figure out ahead of time, oh, it's going downhill. My slope's negative. And there's a rise of 2. 1, 2, 3, 4, 5. Run of 5. This has got a slope of negative 2/5. Okay? Like this one right here. It's going from left to right. It's going uphill. If I find the 2 points they're talking about, 1, 2, 3, 4. 1, 2. So rise of 4. 1, 2, 3, 4, 5, 6. Run of 6. 4, 6 reduces to 2/3. This one, slope's definitely positive. Rise. Ooh, now this one's out in the middle. Okay, so through this. This is up at 4. This one's down at negative 3. So from 4 to 0, that's a distance 4. From 0 to 3, negative 3. So that's a total distance of 7 of a rise. And then here I'm going from 2 to 5, which distance there's 3. My slope is 7/3. Okay. But if you look back on the part from the book, there's also, if this makes more sense to you, like when we say rise over run, we're talking about going up and down, which is a change in the y's over a change in the x's. And you can say that delta y over delta x. That delta in math and science stands for a change in. So it's how much did the y's change over how much did the x's change. And just remember, rise, up and down. Y's go up and down. But that is a formula. So if you like the formulas better, you do changing the y's. Well, how far did this change from here? So what's the difference in them? How far did this change from here? What's the difference in them? So a lot of times we teach slope using a slope formula. So if I did the slope formula, then it's basically you pick a point. Say first point, second point. And that y sub 2 means the second y. It's like my second y is 1 right there, minus my first y of 3. Second x, 1, minus the first y, which is a negative 4. I get the same negative 2/5 I got just by counting blocks. Okay, so this one, let's do the formula. I'm going to take second y minus first y over second x minus first x. So let's say here's first point, second point. So I'm going to do second y minus the first y, second x minus the first x. Yep, same thing. This one might have been easier with the formula because in case you had trouble counting. So it's like if I did the formula here, let's do first point, second point. So I did second y minus the first y, second x minus the first x. That gets me 4 plus 3 over 3. There's that 7/3. Okay. All right, so then D part, what was the slope of the line that we started to graph today's lesson? Oh, look, it was a rise of 2, run of 3, heading downhill. That was negative 2/3. And then our equation, y equals negative 2/3 x plus 1. Oops. Where did it appear? Right there. That's what the m is. It's the slope. Okay. All right. Next thing. So think about the order pair of the point where any linear function crosses the y-axis. It's like, let's just say you drew some random line. Oop, I want to make sure it's right on the money. Okay. I should probably start there. So there's this line, or this line, or this line. But so this is the point over 0 up 1, 2, 3, 4, 5, 6, 7. This is over 0 up 3. This is over 0 down 3. So all those points where we cross the y-axis, it's like, oh, what do they all have in common? You know, it's whatever that y value is, but the x value is 0. So how can we find a y-intercept? Every time we're going to let the x be 0. Okay, so now let's go back to where we started. And it's like, all right, when we graph that, what was the y-intercept of this line? Well, right there. It was at 0, 1. Okay. And our equation was y equals negative 2/3 x plus 1. So if all y-intercepts can be found by letting x be 0, look what happens. If I plug in a 0 for x, I just get 1. I get that number right there because the part with the x in it would just disappear. So guess what that number on the end is? Well, y equals mx plus b. That b then is the y-intercept. And that's where we get y equals mx plus b, and we call that slope-intercept form of a line. Where the m is the slope and the b is the y-intercept. Okay, so sometimes I'm just going to ask you, give me the slope, give me the y-intercept. So y equals mx plus b. Slope, y-intercept. So the slope, and I guess we should probably write that out. Slope is 2/3. Y-intercept is 5. Slope mb. So the slope is negative 4. The y-intercept is 2. There's a 1 right there. mb. Slope is 1. Y-intercept 3. All right. So we just, hang on, I need to plug up the computer. It's getting kind of dead on me. Let's see. There we go. All right. Then back over here. Oh, on the one I just did. Remember, if there's not a number out in front of the x, it's 1. And then if there's not a number added, you can always add 0. So this one, slope is negative 5/4. The y-intercept is 0. Okay, so if you have to graph these, instead of drawing a t-chart, plotting points, figuring out the pattern, and going, we figured out what happens. You start with the y-intercept. So y-intercept of this one's 2, and then you do the slope from there. That slope is a rise over a run. So from that y-intercept, we're going to go up 7. 1, 2. Oh, I'm going to run off the page. I should change my notes. Yeah, I should definitely change the notes. Let's turn that into, let's make it 3 halves instead of 7 halves because I don't want to run off the page. Let's go up 3, rise 3, run 2. Or I could go down 3, back 2. Down 3, back 2. And that would be the same line. Okay. All right, this one, y-intercept of 3. And then rise over run. So if the rise is -6, we're going to go down 6. 1, 2, 3, 4, 5, 6. Run 1. And then you'll have your line. If I do it again, it's going to run off the page.